All right, hello everybody. This is Mrs. Masteller, and we have our next section, which is dealing with Chapter 4, Section 3. We're solving quadratic equations by factoring. One of my personal favorite lessons that we do all year long. I love factoring, okay, because we see it all over the place. You're going to see a lot throughout the rest of the year, so getting the foundation now is going to be key. It'll be handy, so if you need to watch this video, more than one time, just to kind of get the feel for it. But everything's kind of set up in the notes too with logic and with purpose, so I'll make sure I explain that as we go through. Okay, but it says to consider at the top, if you have a times b equals 0, that means one of two things must be true. Either a is 0 and b is just a number, or b is 0 and then a is a number. Okay, I guess logically too, a and b could both be 0, but that probably would not be the case. But anything times 0 is basically going to be 0 then, right? So either a would have to be 0 or b would have to be 0, and the other variable would just have to be a number. So the zero product property is basically what we're talking about. So if we have something like this, if we have that x plus 5 times x minus 7 is equal to 0, that means one of two things must be true. That x plus 5 equals 0, or that x minus 7 equals 0. But solving both of them are two answers you would get. You just subtract the 5, x be negative 5, add the 7, x be positive 7. So in this case, if you plug those values back into the original problem, if I plug in negative 5 as an example, well, that would give me 0 for over here. If I plug in positive 7 for x, well, that would give me 0 over here. Okay, so pretty similar idea as we just said, but again, it's just called the zero product property. Okay, so that's how you solve it. So that's how you complete it after you factor. So if you notice, they already had the factored form of the polynomial, the x plus 5, the x minus 7. Okay, so let's just kind of recap here. Let's go back and review. How do we factor? If you want to solve by factoring, step number 1 is always make sure the equation is equal to 0. So if you look at the very first example, it says equals 0. So we're good to go. We could start factoring. Okay? The first way to factor, these first three problems are all identical, just different numbers. Okay, how you're going to factor this first row, 1, 2, and 3, is just taking out a GCF. Okay, that's always step number 1 when it comes to factoring. Always look for a GCF. All right, these first three, like I said, they all have a greatest common factor that you can take out of both terms. So when you look at the whole entire equation in its entirety, what can you divide out of both of these terms? You could divide out a 3 for sure, then also an x. So guess what? The GCF will be a 3x. Okay, so you're going to write the GCF out front. Now divide each term by 3x. So if you divide this by 3x, divide this by 3x, what do we have? You'd have 3x plus 1 left over. Okay, so at this point we're done factoring. Okay, we're done factoring. All we have to do now is solve it. So by using the zero product property, solving it now for x, you want to set each factored piece equal to 0, so including the GCF. You're going to set that equal to 0, set the 3x plus 1 equal to 0, and now solve for your solutions. So dividing both sides by 3, but x would still be 0, and then subtracting 1 for this one, and then dividing by 3. Our other possible solution would just be negative 1/3, negative 1 over 3. Okay, so two answers. There you go. Number 2, looking at this one, similar idea. So again, just taking out a GCF. Again, the equation's already equal to 0, so we could just jump right into our GCF. So again, looking at the whole thing, what can we divide out of both terms? We could definitely divide out of 5 and an x. So 5x goes out front. Again, write the GCF out front. And then inside parentheses, what's going to be left over after you divide by 5x? You'll have x minus 4. All right, so again, we're done factoring. We took out the GCF. You can't factor anymore. So now you just want to solve it. So set each factored piece equal to 0. So 5x equal to 0, x minus 4 equal to 0. And now just solve. So again, the first one, divide both sides by 5, but that's still going to be 0. Add the 4 to both sides. Get x equals 4. So here's your two solutions. Okay, and the last one, number 3. First thing, set it equal to 0. So you'd have to bring the 4x over to this side. So make sure your equation says equals 0 first before you start factoring. All right, so we're good to go. Now you want to factor. So what's the GCF in this case? What can you divide out of both terms? Well, number-wise, it would just be 1, but you can definitely take out an x from each. So x gets pulled out front. You have x plus 4 left over, and now just solve it. Okay, so we're done factoring. Once again, solving it, set each factor piece equal to 0. So the GCF equal to 0 already gives you an answer. But now when you set x plus 4 equal to 0, solving it, you just subtract the 4, you get x equals negative 4. And there's your solution. Okay? So when you plug these numbers back in, again, keep in mind these solutions, technically what they're representing, they're called the zeros, they're called the roots, they're the x-intercepts. If you were to graph out this parabola, again, these all make parabolas in the end. Anytime you see x squared, it's going to be a parabola. Okay, you would see that it's crossing over the x-axis in these two spots, at 0 and also at negative 1/3. You see it crossing at 0 and also at positive 4. You see it crossing at 0 and also at negative 4. Okay, and a way to even check your solution too, if you're not confident about your answer, if you plug those numbers back into the original problem, so let me just kind of show you my check work here. If I were to plug those answers back into the original, let's just say I plug 0 back into the problem. Okay, so I'm going to have 9 times 0 squared plus 3 times 0. All this should equal 0 in the end. Well, 0 squared is 0. 0 squared times 9, that would still be 0. You get 0 plus 0 equals 0. Looks good to me. Okay, if you plug in the next number, plug in negative 1/3 for x. So if I do 9 times negative 1/3 squared, so this one's going to be a little bit tougher, but we can still manage. 9 times negative 1/3 squared plus 3 times negative 1/3. Again, all of this should equal 0 in the end. Okay, so I plug it back in. Negative 1/3 squared, that's 1/9. So this would be 9 times 1/9. 3 times negative 1/3, that's just negative 1. Okay, so now 9 times 1/9, that's positive 1. And 1 minus 1 does equal 0. So it all checks out. Okay, so if you ever weren't sure about your solutions, plug them back into the original problem. Make sure it all works in the end. Okay, so the first three, again, just taking out a GCF. There's the first three. The next three are pretty much all the same problem as well. What you're going to do for these ones, there's not a GCF. Well, there is a GCF, it'd just be one though, so taking out GCF isn't going to really get you anywhere. But for these next examples, again, first rule of thumb, make sure their problem is equal to 0, which it is. Okay, so what these are called now is called a difference of squares. So I just kind of abbreviate it, DOS, for difference of squares. These are all going to be a difference of squares. Okay, so how do you factor a difference of squares? So think about what that even means. What does difference mean? Difference means you're subtracting. So if you notice, you're subtracting in between, right? You're subtracting. It's a difference of squares. Squares meaning these are perfect squares. So x squared is a perfect square, so is 144. So that means if you take the square root of each one, you could take the square root of x squared. You could also take the square root of 144. The square root of x squared is x. The square root of 144 is 12, because 12 times 12 is 144. Okay, so how does this actually factor? Every single difference of squares looks a little something like this. Okay, so if I factor x squared minus 144, it would just be x plus 12 and an x minus 12. That's it. Okay, so pretty simple, pretty basic. And again, I didn't really mention with the first three problems, but anytime you're factoring, you're basically doing the reverse of foiling. Okay, so again, if this doesn't look right, if you're just kind of scratching your head thinking, well, how the heck does that even work? Well, if you remultiply these back together again by foiling them, you should get exactly what you started with, which was the x squared minus 144. So let me just kind of show you that. Okay, you don't have to do this on your papers or anything, but just kind of watch me for a second. So if I remultiply these back together again, like I said, I should get x squared minus 144. So if I multiply x times x, that's x squared. X times negative 12 is negative 12x. 12 times x is positive 12x. 12 times negative 12 is negative 144. Okay, so look at what happens here. Right here in the middle, these terms obviously end up canceling each other out. Negative 12x plus 12x, those are gone. We have exactly what we started with from the very beginning. So again, just think about factoring like reverse foiling. If you're not sure if you factored correctly, if you remultiply it back together again, you should have basically what you just started with. Okay? So I just want to show you guys that real quick. All right, so we got it factored. Again, difference of squares factors into x plus 12, x minus 12, but now we got to solve it. Okay, so set each factored piece again equal to 0. So x plus 12 equals 0, x minus 12 equals 0. And now solving, subtracting 12, you get x equals negative 12. Adding 12, x equals positive 12. So here's your two solutions. Okay, you can also write your answer like this. That just makes it easier. So just saying that x equals both positive and negative 12, that'd be fine as well. Okay? The next one, number 5. So first, make sure it's equal to 0. So if anything, move the 36 over to this side. So you'd have x squared minus 36 equals 0. Okay, so again, we got a difference of squares. We have a difference. We're subtracting two perfect squares. X squared is a perfect square, so is 36. So again, just think about what's the square root of x squared? X. What's the square root of 36? 6. So it factors into x plus 6 and x minus 6. All right. So from here, just solve it. Again, if you wanted to check it by foiling, you can, but I think I could just kind of prove to in the previous one that this is how it factors. But now just solving, set x plus 6 equal to 0, set x minus 6 equal to 0, get x equals negative 6, and x equals positive 6. Or again, if you want, you can say it like this, x equals both positive and negative 6. Okay, last one, number 6. We got to do something first. This is not right now a difference of squares. So we want to kind of combine what we did in the first 3 problems along with what we were just learning in problems 4 and 5. First thing is actually take out a GCF. So you should definitely notice that between these terms, since they're both even, you can divide them both by 2. So you write the 2 out front. You'd have 1x squared now minus 49 equals 0. Okay, so still factoring, we took out the GCF, but now we just unveiled, what we just uncovered by taking out that 2 is that you do have a difference of squares. Okay, so factoring this difference of squares, take the square root of each, that's x, this is 7. So from here, you'd have 2 out front, this would be x minus 7, and x plus 7. So now we just got to solve it. Okay, so set each factored piece equal to 0. If you set the GCF equal to 0, though, 2 equals 0, that's not going to do anything. So basically, whatever has an x in it, that's what you want to set equal to 0. So because my GCF didn't have an x in it, it was just a number, that's not going to get me anywhere. So our solution lies with these two factors right here. Just set x minus 7 equal to 0, x plus 7 equal to 0, and here's where our two answers lie. You get positive 7, then you also get negative 7. And there's your two solutions. Or again, if you want to say positive negative 7 like this, that'd be perfectly fine. All right, and again, if you ever want to check your answers for these ones, plug them back into the original problem, and it should all work out in the end. All right, so as we saw, so far we got GCFs down. We've seen difference of squares. So now moving on to the next type of factoring. All right, so these next ones. I like to call these ones just kind of basic trinomials. So anytime you have a 1x squared, so as you see in front of the x squared, it's just the coefficient of 1. But you got a 1x squared. These are a little bit simpler to factor. So as an example, looking at problem number 7. So here's how I normally kind of go through and teach factoring just a basic trinomial. So what you're going to do, again, if you have a 1x squared like we do for these next two, we're actually going to lump 7, 8, and 10 together, and then 9, 11, and 12, we'll put those together as well. Okay, so first thing again, make sure the equation's equal to 0, which it is. So we're already good to go with that. But now what you're going to do, okay, I usually set up this little T-chart type thing, if you will. So what you're trying to do in this case, you want to find two numbers that multiply to be your C term, which is positive 9. And those same two numbers that multiply to be 9 have to also add to be your B term, which is negative 6. Okay, so just think about numbers, first of all, that multiply to be 9. So you don't really have a lot. There's either 1 times 9 or 3 times 3. Okay, so how can I get a negative 6 out of this? So again, when I add those two numbers together, they have to add to be negative 6. Well, it's obviously going to be 3 and 3. But to get a negative 6, they would both have to be negative. So keep in mind that two negatives multiplied is obviously going to be a positive. A negative times a negative is a positive. But when you add these, it is going to be negative 6. Okay, so we got our two lucky numbers. Now from here, what are we going to do? So how this guy factors, it's going to factor into an x minus 3 as well as another x minus 3. So two binomials, essentially the same in this case. Again, there's only this special case for this one. Okay, and again, if you're not sure about your factoring, let me just show you again. When you FOIL these two back together again, I'm going to get exactly what I just started with, that x squared minus 6x plus 9. Okay, so again, just watch me. You don't have to do this, but if I remultiply these back together, x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x. This would be positive 9. So when you combine these in the middle, you will have exactly what we just started with. Okay, so we know for sure that this thing factors into x minus 3 and another x minus 3. Okay, so we got it factored. Now, solving it, so again, set each binomial equal to 0, but you're going to see you're going to basically get the same answer twice. You add 3 to both sides, you get 3. Add 3 to both sides, you get 3. So either way, your answer is just going to be 3. Okay, what this would mean on a graph, by the way, what this would mean, so here's your coordinate plane, okay? This would be a parabola. It would be upward facing because your a value is positive, so it's facing up, but it only touches the x-axis at this one spot. So let's just say 1, 2, here's positive 3 on the x. Again, it'd be an upward facing parabola, just touching that one spot, since it only has that one solution at positive 3. Okay, that's what this would mean. But all the rest, as you can see, you're getting two answers for the majority of these problems, but in this one case scenario, it's just touching the x-axis. All right, so pretty neat once you put it all into perspective. Okay, so let's try the next one, number 8, similar idea. So again, this is just a 1x squared trinomial, so I'm going to set up my t-chart. I want to find two numbers that multiply to be negative 16, and those same two numbers have to add to be positive 6. All right, again, just think of numbers that multiply to be 16. You got 1 times 16, you got 2 times 8, and you got 4 times 4. Okay, how do we get a 6 out of that? What two numbers are going to give me 6? Well, it's going to be 2 and 8, right? How do I get a 6 out of that? Well, 8 would have to be positive. The smaller number would have to be negative. And again, bear in mind, they are multiplying to be negative 16. So one of these numbers would have to be negative regardless. But to get positive 6, again, just the 2 would be negative, and then 8 would be positive. Okay, so how this guy is going to factor? It's going to factor into an x minus 2 and an x plus 8. Doesn't matter how you list them either. So if you wanted to, you can even write this out as x plus 8 and then x minus 2. Doesn't matter. It's the same thing either way. Okay, but now just simply solving it, set x plus 8 equal to 0, set x minus 2 equal to 0, then solving for both of them, x equals negative 8, then x equals positive 2. Here's your two solutions. Make that look more like a negative. So negative 8. Okay. All right, I'm going to skip down, like I said, to number 10, because 10 actually goes better with 7 and 8, okay, than the rest of them. So those last three trinomials, those are something a little different. So we're going to lump these all together, going all the way down. Okay. So for this last one, first thing, make sure it's equal to 0. It already is. So next step, as you see, once again, this whole entire equation is reducible by 2. You could take out a GCF of 2 in all three of these. So if I take out a 2, all right, so dividing each one by 2, my GCF, I'm going to have a 1x squared minus 4x minus 21 equals 0. Now what you just uncovered, again, once you take that 2 out, you do have a 1x squared trinomial. Okay, so just a basic trinomial. So what I'm trying to find for this problem is I want to find two numbers that multiply to be negative 21, and those same two numbers have to add to be negative 4. So what multiplies to be 21? 1 times 21 or 3 times 7? Obviously it's going to be 3 and 7, but if I want to get a negative 4, the bigger number would have to be negative this time. Okay, so again, one of those two numbers has to be negative since you are multiplying get a negative. But in order to get negative 4, bigger number has got to be negative. So if this was a positive 4, well, then the smaller number would be negative. 3 would be negative. Okay, so fully factored. You got your GCF in front. This would be x plus 3, then x minus 7, since 3 is positive and 7 is negative. All right, we got a factor. Now just solve. Again, the 2, the GCF equal to 0 is not going to get me an answer because there's no x in it. So my answer lies just with these two binomials. Set x plus 3 equal to 0 and x minus 7 equal to 0. Subtracting 3, you get negative 3. Adding 7, you get positive 7. There's your two solutions. All right, so we've seen basic trinomials. Now here's the more complicated ones. All right, these last guys. When you have a trinomial that is not a 1x squared, what you're going to do instead is what's called the guess and check method. Okay, so you're going to place a guess and you're going to check it. How you check it is by foiling them back together again. But again, first make sure your equation equals 0. So I'm going to subtract the 5x and subtract the 2 over to this side. And I like to do that instead of subtracting 3x squared because I like to have a positive a value, just personally. I think it's easier to factor with. Okay, so if I move everything over to the left-hand side, here's where we got 3x squared minus 5x minus 2. But if you subtract 3x squared to the other side, it still all comes out the same in the end, the same answers, but again, I just think it's easier to factor with a positive a. Okay, so starting off, because we do have a 3x squared, the start of my binomials would have to be a 3x and a 1x, because 3 is a prime number. Only 1 times 3 is going to be 3. So again, if I FOIL these back together again, I want 3x squared. So a 3x and a 1x will give me that 3x squared. Okay, here's the rest of it. How do you fill out the rest of the binomials? You want to think about what multiplies to be negative 2. Okay, so here's kind of the guessing part. What multiplies to be negative 2 is either 1 times 2 or 2 times 1. Okay, that's it. That's all we have. But the placement is key. Where do I put the 1? Where do I put the 2? So take a guess. Think about it. Let's just say you want to put 1 here and 2 here. Okay, so keep in mind, too, that's negative 2. So now you have to place your guess as to which one's positive, which one's negative. So let's just say you want this one to be positive and this one negative. Okay, so now I'm going to check it. How do I check it again? I FOIL these two back together again. So just remultiplying them back together, 3x and x, or you know that's 3x squared. 3x times negative 2 is negative 6x. 1 times x is 1x. 1 times negative 2 is negative 2. And now when you combine these like terms, you get 3x squared minus 5x minus 2. That's exactly what we started with. Okay, so I'm good to go. I know for sure that this thing does not factor into anything else besides 3x plus 1 and x minus 2. All right, so I got it factored. So now, I'm just going to go ahead and solve it. So I'm just going to set 3x plus 1 equal to 0. Let's set x minus 2 equal to 0. And now solving, I'll do the easier one first. Just add 2. You get positive 2. This one, subtracting 1, and then dividing by 3, you get negative 1/3. Okay, so there's your two solutions. All right, so there's guess and check. I know I made that look super easy, but it does get a little bit tougher. So let's try a little bit harder one. Let's try number 11. So first thing again, make sure it's equal to 0. So I'm just going to move the 12. Just going to subtract it over here. So we get 4x squared minus 13x minus 12 equals 0. Okay, what makes this one so much harder? Well, because 4x squared, if you think about it, 4 is not a prime number. This could factor into one of two ways. It might be a 4x and a 1x, or it could also be a 2x and a 2x, right? So both of those can give me 4x squared. So we're going to kind of try and play around with both of them. So whichever one you prefer, whichever one you'd like to start with that one, okay? But now the guessing game also comes in with what multiplies being negative 12. So to finish out these two binomials, you want to think about what multiplies being negative 12. Well, it could be 1 times 12, it could be 2 times 6, or it could be 3 times 4. So again, just think about it, place a guess, whichever one you want. Okay, I'll give you a word of advice too. If you were to put, let's just say you tried 2 and 6. I could tell you right now that this is not how it's going to factor. The main reason is because you just made a GCF over here. Okay, if there's a GCF here and you're factoring, that means that there was a GCF from the very beginning of the problem. And in this case, there wasn't one. Okay, so guaranteed it's not going to be 2 and 6, even if you switch around the two numbers. So even if I switch around 2 and 6, if I put 6 here and 2 here, well, there's still a GCF. Between 4 and 6, you could still take out a 2. So automatically, I'm just going to rule that out. Okay? So it can't be 2, and it can't be 6. We'll rule that out. Even if you place it down here, right? Even if I put 2 here and 6 here, this is a GCF, this is a GCF. That's not going to work. My eraser's not working very good, guys. I don't know what's going on. Come on. Okay. So 2 and 6, not going to work. So let's say 1 and 12 seems like it's going to be way too big, personally. So if I put, 1 here and 12 here as an example. So as I start to FOIL this out, I get 4x times x is 4x squared, but then 4x times 12, that's 48x. All I want in the middle, though, is negative 13x. That's all I want. Okay, so I'm not going to say, I would say that 12 and 1 is probably not going to work either. So even if I switch the two numbers around, again, if I put 12 here, and let's just say I put 1 here, again, here's a problem. That's a GCF between 4x and 12. So I'm going to rule that out. Okay, so I'm trying to give you guys some pointers as to your factoring and how it all works. So I'm going to rule out 1 and 12. So that just leaves us with 3 and 4. Well, think about the placement. 3 would have to go here with 4 and 4 over here, because if you place the 4 where the 3 is at, that's going to make a GCF. Okay? So again, I'm trying to give you guys some pointers as to how to, strategize and just problem solve your way through it. So now from here, okay, so let's just play around with this first one. 4x, 3, and then we got an x and a 4. Well, again, it is multiplying to be a negative 12. So think about which one you want to be positive, which one you want to be negative. So let's just say you put minus here and plus here as an example. Okay, so let's check it. If I FOIL these back together again, I'm going to get 4x times x gives me that 4x squared. 4x times 4, that's positive 16x. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. If you combine these right here in the middle, what's 16x minus 3x? That's positive 13, right? But we want negative 13. So what does that mean I have to do? One and only thing. Just change your signs. All right? If you just change your signs, you should be good to go. If I make this one instead positive and make this one negative, that's going to give me 4x squared minus 16x. All right, 3 times x is plus 3x, and then 3 times negative 4 is still going to be negative 12. But when you combine these now, that's going to be negative 13x like you want. Okay, so I don't even have to play around with the other one. I have how this factors. I'm good to go. So I know it factors into 4x plus 3 and x minus 4. So I'm just going to bring that down to solve it. Set 4x plus 3 equal to 0. Set x minus 4 equal to 0. So now solving, let's subtract the 3 and then divide by the 4. So negative 3/4, there's one answer. Add 4 to both sides, you get positive 4. Okay, so it really is, there is some strategy to it. It's not just completely guessing and checking. Okay, so think about the strategies I'm trying to tell you. We'll see that again in the next one as well. This equation is already equal to 0 though, so there's nothing to move over. So it's already equal to 0. So all I'd have to do here, there is no GCF between 5, 34, and 24. So we got to do the guess and check. Okay, so just set it up. Two binomials. Here we go. 5x squared. Well, thankfully 5 is a prime number. It has to be 5x and 1x. Okay, but 24. There's a lot of factors of 24. Yeah, 1 times 24, 2 times 12, 3 times 8, 4 times 6. All right, so take a stab at it, whichever one you want to place first. So again, think about like 1 and 24, that might be a little too big. Typically it's not going to be 1 times that number. Typically it's something farther on down the list. Let's just say you want to do 2 and 12. Okay, well they're multiplying to be a positive 24. So positive 24, and they're adding to be positive 34, so these both have to be positive. All right, so as I start to FOIL this, this would be 5x squared. That'd be 60x, which is already too big because we want 34. You'd have plus 2x and then plus 24. So that's 62x. That's way too big. Okay, so that didn't work. Maybe you want to switch them. Maybe you want to put 12 in the first one and then 2 over here. So what happens if you switch them? You'd have 5x squared plus 10x plus 12x plus 24. 10 and 12, that's 22x. Again, we want 34x. So that didn't work. Okay, so we can rule that out now. It can't be 2 and 12. Let's try the next one. Maybe you want to try 3 times 8. So let's put 3 here, let's put 8 here. So that'd be 5x squared 5x and 8, that'd be 40x. 3 and x is 3x, so that'd be 43x. Okay, again, we want 34. So far that didn't work. Again, if you want to switch them, 8 here, 3 here. So this would be 5x squared, 15x, and 8x. So 15x and 8x, that's 23. We want 34. Okay, so it obviously can't be 8 and 3. Rule that out. So hopefully now it's 4 and 6, because again, 1 and 24 is probably going to be way too big. So if we do 4 and 6, let's say 4 is here, 6 is here. That'd be 5x squared. 5x and 6 is 30x. 4 times x is 4x. That's 34x. Looks good. 4 times 6, that's 24. Looks like we're all set. Okay, so you almost have to kind of visualize where you're placing the numbers before you even place them. Okay, you have to envision multiplying these out together before you even place the numbers down. That'll help you out significantly. So as long as you're good at foiling and multiplying two binomials together, that'll help you out a ton and save you some time and effort. Okay? But now solving, set 5x plus 4 equal to 0. Set x plus 6 equal to 0. Solving each one, the easy answer, negative 6. Subtracting 4 gives you negative 4. And then dividing by 5, you get negative 4 over 5. So there's your two answers. All right. I know that those took quite a while, but the more practice you get with these types of problems, the better you'll get at it. I guarantee you that. Okay, and if you notice too, you basically get a fraction answer every time when you have these guess and check type problems. Okay, that's going to kind of help you with the next part. So let's go ahead and turn the page on the next page. Okay, you're basically going to work these backwards. It says we can work backwards also. So given the roots, you have to write the quadratic equation. So the roots, we're given the roots, right? Basically, we're given the solutions. That's what the roots are. Okay, so you got to work these backwards. So for 13, we know that x equals negative 4, and we know that x equals 7. These are the solutions. You got to work it backwards. Where do these solutions come from? What quadratic equation did these become or get derived from? Okay, so to work it backwards, let's even flip back here. So how are we going to work it backwards? Let's just look at an example. Let's look at like number 8. Okay, so we have the solutions. How do we work it backwards? Well, from here, if you go back to the previous step, you want to set these equal to 0. Then what you're going to do is take these two, just multiply them back together again. That's it. Okay? So let's apply that over here. All I'd have to do is set each of these equal to 0. The x equals negative 4 and the x equals 7. If I want to set this first one equal to 0, I just add the 4. So I get x plus 4 equals 0. This one I'd have to subtract the 7. So I get x minus 7 equals 0. Okay, set them equal to 0. Now what? Take these two and multiply them together. So take x plus 4 and x minus 7. Just FOIL these two together. You get x squared minus 7x plus 4x minus 28. So that's x squared minus 3x minus 28. And there you go. You're done. Okay, so same thing for the next one. We know the answers are 5 and negative 5, but now work it backwards. This is x minus 5. This is x plus 5. So take these two binomials, multiply them, x minus 5 and x plus 5. Multiply these two together, you'd have x squared plus 5x minus a 5x minus 25. All right, combine your like terms, but these just cancel. And guess what? You got a difference of squares, which makes perfect sense based on those answers up there. Because we look back at the difference of squares, again, you get positive and negative 12, positive and negative 6, positive and negative 7. So when you have the same answer twice, just one's positive, one's negative, that should make a difference of squares. Okay, for 15, we know the answers are negative 2 and 0. Okay, so x by itself is basically going to be a factor because it's already equal to 0. So that first one, though, just add the 2. So you'd have x plus 2 equals 0. So here's your two factors, x plus 2 and x. You're just going to multiply these back together again. So just distribute x back together and get x squared plus 2x. Okay, that's the original quadratic. What about for fractions, though? So again, we know the answers are 1/2 and negative 5. These are the roots. Okay, so you're not going to do this with a fraction. Don't just subtract the 1/2 like this. That's not where that answer came from. So think back. I'm going to flip back here. How do we get a fraction as an answer? Let me go down to these bottom ones. How do we get this negative 1/3 as an answer? Well, we had to subtract 1 and then divide by 3. So it's going to actually take 2 steps to work it backwards. Okay, to put this back into its original form, first thing you're going to do, multiply both sides by 2. So that cancels the 2 out. You have 2x equals 1. Okay, then subtract the 1. You have 2x minus 1 equals 0. This is the original binomial, 2x minus 1. That gives you the answer positive 1/2. So if you have x equals negative 5, just add the 5. You get x plus 5 equal to 0. Here's the other binomial. So those are the two that you want to multiply together. Okay, so 2x minus 1, multiplying with it, x plus 5. So we get 2x squared. We get a 10x minus 1x minus 5. Combine your like terms, you have 2x squared plus 9x minus 5. That's the original quadratic. All right, so same thing for 17. We have x equals 1/3, x equals 4. So to work it backwards, multiply by 3 first. So you have 3x equals 1, so just multiply by the denominator. Then just subtract the 1, so 3x minus 1 equals 0. There's my first binomial. For x equals 4, just subtract the 4, so x minus 4 equals 0. All right, so there's our two binomials. Now just multiply them, 3x minus 1, timesing it by x minus 4. We get 3x squared minus 12x minus 1x plus 4. Like terms gives me 3x squared minus 13x plus 4, and that's the original quadratic. Okay, so you should be able to find and derive the quadratic given the roots. Okay, just work it backwards. Last and final, got a little real-world problem for you. It says the entrance to an office building is an arch in the shape of a parabola, whose vertex is the height of the arch. The height of the arch is given by h equals 9 minus x squared, where x is the horizontal distance from the center of the arch. Both h and x are measured in feet, so how wide is the arch at ground level? Here's your main question. All right, I like to draw pictures to this. So again, it's saying that we're in an office building. Let's see, the entrance to the office building is in the shape of an arch, okay, in the shape of a parabola. So let's just say entrance of the building, here's the doorway, okay. The vertex up here at the top, in this case, the height of the arch, so how tall this arch is, so from the ground, just say here's the ground level, to the vertex, the height is 9 minus x squared, where x is the horizontal distance from the center of the arch, so going from the center of the arch and then going out. That's what x is. Okay, both h and x are measured in feet, so how wide is the arch at ground level? The key words right now, we're saying at ground level. Well, if I'm at ground level, what's the height going to be? If I'm talking about the ground, the height would be 0. 0 minus, or 0 equals 9 minus x squared. Think about it like that. Okay, so from here, okay, so again, at ground level, the height's just going to be at 0. We want to know how wide the arch is, though. So we want to know the width, the full width. How wide is this thing? That's the question. Okay, so basically, if we can solve this thing for x, x just goes from the center of the doorway and then out to the edge. If you just double it, then you'll have the full entire width, right? So let's just solve this thing for x. So how are we going to solve this for x? Well, let's factor it. It's a difference of perfect squares, right? These are both perfect squares. This would just factor into 3 minus x and 3 plus x. So if you solve these, set 3 minus x equal to 0, set 3 plus x equal to 0, you get x equals negative 3. You subtract the 3 and then divide by negative 1, you get positive 3. Okay, here's our two solutions. But obviously, again, if we're talking about, you know, a distance from the center going out, distance can't be negative. So x would have to be 3 in this case. So this would be 3 feet. Okay, now from here, it's feet, right? Yep, so h and x are both being measured in feet. So again, we know from the center going out is 3 feet. So if you double it, the full width would have to be 6 feet. That's your final answer. All right. So I know that was kind of a little bit lengthier than most lessons, but factoring again, like I mentioned, it's super important. We're gonna be using it a lot throughout the rest of the year. So if you have further questions or need some more practice problems or anything like that, just let us know. Otherwise, have a great day.